everyone. As Nicolas said, my name is Nicolas Boisvert. I'm an Elixir and Helm enthusiast, a React lover. I love writing clean code, and I'm a fresh new functional adept. All my handles are on the screen, so if you want to check me out on social networks or anything. So I work as a full-stack developer at Ramen Code in Shawinigan, and yes, I did 2 hours of driving to be here tonight with you, as I did for all the other meetups. This leads to something that I want to just give a second to thank Mibrigo and Civil Code to let me present here. I never thanked them before for this great opportunity, and this is my third talk, so I really appreciate the opportunity. So I wish this event can live as long as I can, so I encourage you all to come here and teach things to my newbie brain. So tonight we're about to EScript the hell out of this. We are going to build globally executable binaries for our application. These features come in handy if you have application where you have logic coded but no public entry point. What I mean by that is that you can easily use this in a container or in a server to talk with your application without having to open an IE shell or using a web application or anything, or an API or anything else that could be an entry point to your application. But a little disclaimer before going on, the documentation states that it should not be used as a deployment tool. You should use proper tools such as mixed releases or this theory for older mixed version, Elixir version, sorry. So what they are. First of all, escripts are a binary executable that, as I said, which are bundled with Elixir if you wish to, but you're not forced to. We'll talk a bit about it later. Which can be run on any Erlang or OTP system installed. So they can use apps applications. So if you have Ecto or any external dependencies that run their own process or things, you can use them in your binary. They also receive command line arguments, so they can be great tools for CLI and can be either Erlang or Elixir. What I said in the first point is that you can bundle Elixir, but you're not forced to. You can be writing a whole Erlang application, so this would reduce the size of the binary. So how do we create one? So the first step is to create a module that exposes a function that has an array of 1. So let's take a look at this. So let's create a new project, an empty DOM project. Yep, sorry. This is awkward, okay. Good. Whoops. I am. 3. So let's create our module. So we will use the basic modules. We don't need to create another one. So let's delete this and create the main function. Yeah. So now that this is a super useless CLI, we will now get back to the next step. So if I get back to the presentation, we now need to register the module in the mix EXS files, because mix has to know how to build the actual EScript. This is also a simple task. So there's this key that we can add, which is EScript, which can receive the keyword list of options. The main option that it needs is the main module, which references the module to use as the script. So for in our case, it's meetup 3. And that's done for the registering. We could add some other options to, like, as I said before on, to bundle Elixir or to rename the application. For instance, I'm gonna name this CLI, which is more cute than meetup 3. And you can bundle other options like using apps or anything, because, for instance, in an application that I wrote, I had some other application that were running that I didn't want to run. For instance, Ecto. I didn't want to run Ecto when I use my CLI, so I simply disabled the application in the application function, so my CLI runs without Ecto because I don't need it anyway. And then we have to build the actual EScript. Oops. So the simple command is mix escript.build, and it's done. It compiles a file and generates a binary. So as you can see, I have the CLI hat here, which weighs a huge 1 megabyte. This is the whole application that I have, so if I run it, it outputs an empty array because I don't have any arguments. But if I go and I add arguments, then I have an array of strings. So that's pretty much the basics of writing in EScripts. But there's other things that are way cooler when you use this, which are, for instance, installing the EScript, because it could be great to use this in anywhere in your system. So for instance, just hold on. Okay, I could be writing mix escript.install, which will install the binary in a I did some tests, as you can see. It installs the CLI in a global path environment variable. So for instance, if I check out my path environment, which is kind of huge, I have I don't see it, but you have somewhere here a mix bin. Where is it? Okay, I can find it. And I should be able to call. It's not going well. That's because I did the whole presentation on my Mac Mini at home, so I don't have the exact same setup on my laptop, but you get the main idea that I have to finally register the path in my path environment, and they are globally accessible. The first time I did it on my Mac Mini, it shows me the actual path where the bin was installed, but it did not this time, so I don't even know why. But that's pretty simple to get. You only have to check out the documentation. You have the relative path to get the location. So let's get back to the talk. But you might be wondering, do I have to handle the options by myself? Because of course, handling options is always a pain in most of languages. But I have an answer for you. You have pattern matching, which is one of the most awesome features of functional programming. You might be saying, yeah, right, but not all kind of options can be done using pattern matching. Like, for instance, fetching an option that has an aliases, so like -e or dash exact, for instance. You cannot get this by pattern matching. I have another answer for you, which is called the option parser. The option parser actually is a module that can be used to easily parse options. It exposes to a function which is parse and parse head, that has a array of 2. So the first part is the array of the list of arguments, and the other part is the kind of the template that you want to use. So as you can see in the example, I set out the strict, which has a debug flag, which is a boolean. So if I have the flag -- debug in my arguments, then I have debug true in my keyword list. So as you can see at the output, we have a tuple of 3 values. The first is a keyword list of options that have been parsed successfully. The second is a list of arguments, so which does not contain any dashes or any dashes at all. And the third value is a list of considered invalid options. So as you can see, I have a more concrete example for you, which is a more valuable example. So we have a flag, simple flag, which I said that it's a boolean. So I have -- flag, so in the bottom the flag is true. After that we have a -a that is not referenced in strict, but in aliased, in aliases you said that a is an alias of aliased. Then in the bottom we have alias to true, because I have the -a. We can negate argument, because if I do not provide -- flag, then the tuple is not visible at all in the list. So to negate the option, we can prefix with -- no. We can have values that's a type of string. So as you can see, value has a string, so it takes the values next to the option. So which is, for instance, my value, and you have in the keyword list in the bottom, my value as the value of value. Pretty obvious. After that we have an argument which does not have any dash or is not prefixed by an option, so it gets into the second list. And in the third The third option we have invalid, because invalid is not referenced anywhere in the strict or aliases or anything, so it becomes invalid. You can switch the strict for a switches key, which makes it more less strict, in fact. So you can provide options that does not match the type. So I can have a flag that has a value. It will match anyway. You can have some options that are not required at all to be present in the tuple. So you can have a lot of things in that helps you to handle options in the CLI. I have a concrete example, which I add in my application. So this is a project that I wrote. That is, I'm a big fan of board games. So this is this is a project where I use the Board Game Geek API, and I did a CLI, for instance, to fudge. Sorry for the interruption. Okay, now, so I did a CLI to easily fetch the Board Game API from my console. So here's the module, and this was written before I knew about the option parser, but this gives you a clean example of how we can do it with pattern matching, for instance. So the basic main point that we have is search, so you can search for games. If I got it, I parse the arguments, and then I call the search function. We have get, which needs a ID and gets the game information. And after that, we print the help, which is a string. Oh, not that one, which is a string. So parsing the arguments is a bit complicated when you don't have option parser. Here's an example. So I have a list of arguments, and then I call the function that is filter option. The filter option function filters the arguments and checks if it's an option. To see if it's an option, it starts with a dash, but not with a double dash. So it's pretty solid. So, and to filter the arguments, I do the same, except that it's not an option. It's a clever trickery. And I get a cute tuple of options and arguments that I can pass to my search or get function. So the search function here, I get options and the string, and then I check if I have the E flag this way to see if I want to check with exact keywords. So it's a bit complicated if you don't have option parser. I could reduce this module by half if I use option parser, which I obviously will do this week maybe. So let's see what it can do if we use it. This is a bigger application, so it takes a bit longer to generate, but not that long. And since this is a full Phoenix application which has a lot of dependencies, it's still a kind of 7 megabytes, so it's not that huge for a CLI. It's pretty cool though. So if I go ahead and try it, search for a game that is called Agricola, for instance, and then I have all the results. That's cool. But I want the exact, so as I said later on, the dash E flag. With the way I did it, I could not write that dash exact because that's the limitation of my own option parser. But you get the main idea of how we can use it, and then I could call the other function, which is get, to get the game information. Then I have the whole game information. So this is pretty basic, but you get the main idea of writing and EScripts actually. So I did found a lot of use case for this. So for instance, in an application in production that we have, we built an EScript which helps us to invite users, because we're on steps that we don't have admin panel where we can invite administrator or things. So instead of always going to IEX and calling the context function with the email, I can easily call it with a makefile with an SSH remote command and simply invite the administrator from remote actually. So that's a basic use case, but that's a cool use case where we save a lot of time. So thank you for being here. I hope you'll have a good time writing EScripts, and don't hesitate to follow me on social networks. And if you are looking for a contributor to your project, I'm always happy to help. On a final note, I'm currently reading the Learn New Erlang for Great Good book by Fred Hébert, and I highly recommend it to anyone here. I'm only at chapter 4 and I already learned things about Elixir. That's an awesome book, so I recommend it to you. And thank you for being here.
Thank you.